let's begin with just this is a small recap of 5 minutes. How many digital input output pins are there in Arduino? We have 14, right? We have 14 digital input output pins in Arduino. And how many analog inputs are there? Right. So there are 6 analog input pins are there. The microcontroller present in the Arduino can understand only digital. But if we can accept analog input, what is the thing that is used to convert this analog to the digital? ADC it is called. It is called analog to digital converter. It accepts the analog inputs, but those analog inputs are converted to the digital form so that microcontroller can understand. So the next question, what kind of microcontroller is present in Arduino? It is at Mega 328. At Mega 328p. So this is a microcontroller that is there in the Arduino. That is something, it is having a 8-bit processor. It is having a 8-bit processor. So with the help of that processor, it can process any of the code that we are giving. What is the name of that software where we can write the codes? It is Arduino IDE. It is a Arduino IDE software that is where we can write the code, and those codes can be uploaded to the Arduino through the USB port. USB port is there, and through the USB port any kind of code can be uploaded into the microcontroller. So we have 6 analog inputs. We have 6 analog inputs. We have 14 digital input outputs. We have how much supply is required for the Arduino operation? How much supply is used? It is generally 5 volt. It is generally, most probably, it is always 5 volt. What we call that negative terminal of the supply, or where we connect the negative terminal of supply? That we will connect to the ground, GND, ground of the Arduino, right? So we have certain supply pins. We have 14 digital input output pins. We have 6 analog inputs, right? These are the main pins present on the Arduino. What is the name of the wires that we use to make the connections? Those wires are called jumper wires. So today what I'm going to give you, last day we have learned that how to use a digital pins, how to use those digital input output pins. Today we will learn about the analog pins. So in analog pins, this is the component that we are going to use. This is potentiometer, right? This is a potentiometer. It is basically something that is treated as, that is called as analog sensor, right? It is called as analog sensor. It is treated as analog. That means it will give you the output that is analog in nature, right? Last day we learned about the LEDs. Last day we learned about the LEDs. So LED is something that can give you either high or low, that is 0 or 1. That is something that is digital. Here it is a potentiometer. It is something that can give you a analog output, that is a range of output, right? It will not give you only 0 or 5. It will give you all the values from 0 to 5. From 0 to 5. So let's begin with this. So it has 3 terminals, right? It has 3 terminals, 1, 2 and 3. These are the 3 terminals of potentiometer. So this terminal EI and this ground, these two are for the supply. For the supply, here we give the positive terminal of the supply, and here we connect it to ground. So this positive terminal will be connected to 5 volt of Arduino, and this ground will be connected to the ground of Arduino. This is the terminal where we get a output from the potentiometer. It is EO. This O is depicting, it is a output of the potentiometer. What output voltage it will give? As I have told you, the input that we are giving over here is 5 volt. What output it will give? That will be by this slider. Position of the slider will give us the output voltage, where this slider is, right? this slider is movable. It can be from this initial point, it can be moved from this initial point to this final endpoint, the final position. When this when this slider will be on the initial, when will be over this end, when this will be over this end, what output it will give you? It will give you whatever input we are giving, whatever we are giving, whatever input we are giving 5 volt over here. So if it will be over here, the output will be 5 volt only. The same, whatever input is, the same will be the output. So as we will move this slider from here to here, the output voltage will keep on decreasing as this value will be increasing. As this R1, as this slider will move away from this initial position, the output voltage will keep on decreasing. So in this center, it will be exactly half. Can you tell me, if I have connected this to Arduino, what will be the output voltage over here? It will be half of the input. It will be exactly half of the input, because R1 and R2 both will be equal. We have divided this whole into two parts. It will be equal. So it will be 5 by 2. It will be 2.5 over here. So when we'll move over here, when it will reach over here, what will be the output? That will be 0. From here, are you getting that why I'm going to analog? Because it is giving you all the values from 0 to 5. It is giving you the output that is from 0 to 5. LED was giving us off, 0, on, that is 5. When it is on, that is it is 5. When it is off, that means it is 0. So this is something that is giving all the values, and that value is reflecting in the terms of voltage. So let's begin with the Tinkercad. Let's make a circuit potentiometer. Please do it with me, then only you'll find it valuable or interesting, because you parallelly will be doing, and then only you'll be learning. When you enter, you go to circuits. Let's go to create new circuit. Go to all, get a potentiometer. So in this potentiometer, firstly try to learn what I was talking about in that diagram. You choose a battery. You choose a battery, 9 volt, right? Positive of this battery connect to this terminal. Negative of the battery you connect to this terminal, because these two terminals I have told you, here we can give a input, positive terminal of the supply, and here we have to give you it a negative terminal, that is ground, right? And this is the wiper where we can have a output. Now we want to see what kind of output we are getting. So in that case, here we don't have anything to check the output. Go to the multimeter, right? Go to the multimeter. What multimeter is? Multimeter is something that can measure voltage. If you see here, it is measuring voltage. Here, if I'll go to A, it will measure current. Here, if I'll go to R, it will measure resistance. But here we will use this multimeter as a voltmeter. So it is this positive of this multimeter you connect to this wiper, because we want to see what kind of output we are getting. So we will get this positive of the multimeter connect to this wiper, and negative of the multimeter you connect to this ground. After doing this, you start simulation. Here it is giving me, here the position is on initial position. So it is giving you 9 volt. It is giving you 9 volt. So as you will move this wiper, you can see that it is changing, and it is covering all the points from 9 to 0. From 0 to 9, it can measure all the voltage. So that is what that is. It is analog in nature. As I am moving away from this end, that R1 is increasing, and that position, the displacement of fiber is decreasing the voltage. And if I'll move it to the extreme end, that means here the R1 is maximum. In that case, the voltage will be, output voltage will be 0. This is just to give you an idea about the potentiometer, that this is what the potentiometer. Now stop the simulation, remove this battery, delete this battery, delete this multimeter, you get a Arduino. These two things we need, one is potentiometer and one is Arduino. Potentiometer working, I hope you have learned. So here the terminal 1, this terminal 1 we will connect to 5 volt, 5 volt of Arduino. And this terminal, terminal 2, connected to ground. So now, can you tell me where will I connect this Viper output? It is analog. So this is Viper that we will connect to any of this analog. Any you can choose. Let A naught I have selected. Right? You can choose it as any of this analog. This is giving us analog output, and that output we have to accept over the Arduino. So Arduino, we have 6 analog inputs. You can choose any of the 6. Let's go to code. So here we are accepting our input. From where we are, I'm telling you the other way. I'm telling you the other way. Here we have a text and a block. I'm going to, because last day we did it by text. Now I'll just give you an idea how we can do it with blocks also. So in blocks, keep it blocks. Go to input. Here choose this read analog input. We have to read analog input. Here you need to choose which analog input you are using. I have connected it to A naught. You can, wherever you are choosing A naught, A1, A2, whatever you are using, you have to choose it accordingly. You can choose it like this. So if I'll connect it to A3, I can make it change. I can choose from here, I can make it A3. Right? If I'm using A naught, A1 or A naught, whatever you have to use, whatever you are using, you have to choose that. Then for now we have to, no, we have to see that what we are getting, what the Arduino is reading at this pin. So go to output, then choose this block, second last block, where it is print to serial monitor. Print to serial monitor. This block I'm talking about. So this is a serial monitor. This is a serial monitor where we can display whatever input, this analog input this Arduino is reading. Then what you have to do is you have to choose this block and put it over hello world. You start simulation. Go to serial monitor. This position of the Viper is on the other end. So that is why I'm getting 0. When I move this position, when I change this position, I am getting a voltage. So here when I am on the other extreme end, there I am getting 1023. This is what? This is 5 volt. How it is 5 volt? Is because this analog input is converted to the digital form. It is with A to D converter. It is converted to the digital form. When 5 volt is converted to the digital form, in this Arduino board, there are inbuilt 10-bit A to D converters. There are inbuilt 10-bit A to D converters, with the help of which anything that is analog given over here, that is converted to the digital. And when 5 volt is converted to the digital, with the resolution of that A to D converter, it is converted to this value. 5 volt is 1023. When you move it in the center, that means we were talking about that it is 2.5 volt. The 2.5 is approximately 512, and when you'll move it along, it will keep on decreasing and it will go over here. this is just to give you a clarity that how 5 volt was. It is a 10-bit A to D converter. It is a 10-bit A to D converter that is basically converting that 5 volt to 1023. 2 raised to power 10. 2 raised to power 10. So resolution is 2 raised to power 10 minus 1. 2 raised to power 10 is 1024 minus 1. So 5 volt is 1023 by A to D converter. Then this 5 volt is converted to digital format. There is inbuilt 10-bit A to D converter which converts it to the 1023. If it is 2.5, it is 512. So here you can on your extreme right corner you have this uh, this is where we can see an analog waveform. We can see the waveform also. Now start the simulation. Change this position. You change this position, you will be getting a clarity that why I was talking it as a analog. It is analog. The position of the wiper, it is giving us a analog thing. The thing that we are getting over here, that is given in the graphical in the analog form. So now we need to learn it in the same way. You can go to this, keep it same and go to this block, go to text. You press continue and it will give you in what we have done. It will give you in this format that we did the last day. So here pin mode is specifying that which pin we are using. We are using A0. We are using A0 as input, and we are, you come to the serial loop, serial void loop. Here it is serial dot print line. It is analog read. What we are reading analog read A0. We are reading this A0 and we are printing it on a serial monitor, right? Then you might be confused with this thing. This is basically it is from this control, from this microcontroller. It is reading it and it is sending it to the monitor. The speed at which it is sending, that is a baud rate. This is called baud rate. This is called, what this is called, this is called baud rate. And this baud rate is 9600 bits per second. It is 9600 bits per second. That this is the speed at which this Arduino is sending that thing serially to the monitor. Speed at which it is sending it to the monitor, right? That is 9600 bits per second. So that is the purpose of this thing. This I hope is clear. This is to print what we want to print, whatever we have read over this pin. When it is a digital, it is either on or off. It is, if it is on, that means it is 5 volt. If it is off, that means it is ground. And when it is analog, that means it will have all the values from 0 to 5. This is potentiometer, which is an analog sensor, where the change, this displacement of the wiper is converted to a voltage form. Sensors are basically the transducers which convert one form of energy to another form of energy. They sense any of the physical phenomena. If it is a temperature sensor, that temperature is recorded and it is reflected again in the term of electrical quantity, that is a voltage. When we change the temperature, we have placed a temperature sensor anywhere, that temperature will be reflected in terms of voltage. So the sensors are something that can measure the physical phenomena. That is one form of energy that they accept and they convert it to another form of energy, that is generally electrical. That is a measurable quantity, that is generally in a voltage terms. So one that we did last day, that was to give you an idea that how we can use a digital input output pins. And today we did that what we can use with the output, when we can use this these analog pins. So the next thing that I'm going to explain is let's go to the home page and we will start with the uh, new circuit, and there we will about a push button. push button, and according to that I'll give you one small task and you will be doing it with the push button and LED, right? So you can start with a new circuit, and there you take a Arduino, and with that you take a component that is a this button. You go to this button, it is called push button. Place it, just forget about the connection, just keep it over here. I'm just explaining the terminals, then I'll explain the connections. So here this push button has terminal 1A, 1B, 2A, 2B. So these buttons, when it is released, that means when we have not pressed it, these act as a open. That means they are not connected to each other. But when we press this button, these pins get connected to each other. These button terminals 1A, 1B, 2A, 2B, they all are different. They all are different. When it is released, when we press it, they get internally connected. They get internally connected. And this is how, when it is open and when it is closed, when it is open and when it is closed, so accordingly it will give you the output that is 0 or it is 1. It is 0 or it is 1. So how to make the connection? Just start making with me. This terminal 1A, you drag one register, place it over here. This terminal, through this register, connected to 5 volt. The other terminal 1B, you connect to any digital input output. You connect to any digital input output. So this 2A, you connect it to ground. Now this push button, we are accepting a input from this. We are using this 4. When I go to code, when I go to input, what I need to choose? Read digital pin. Which pin? Here I am using 4. So whichever you are using, you can choose that. Here I am using 4. So I have taken 4. Then we need to go to output. You go to print to serial monitor. Print to serial monitor. You fix it over here and start simulation. When you start simulation, this button is released. It is giving 1. When you just press this button, it will give you 0. When you press this button, it will give you 0 button. When you press it, it will get into the connection. When you release it, it is out of the connection. So what the purpose of explaining this is, now the question is, now the thing that you have to do is, you have to control with this push button, you have to control a LED. Connect any of the LED, make that LED on and off with this push button. So what we need to do, we need to take one LED. We can take LED. Through this register, you connect this LED, any of the pin. I have connected it to 12. Cathode, you connect to ground. Now my question is, you have to control this LED with this push button. You will take a condition: if this button is high, this LED should glow. If this button is low, this LED should be off. And this position of the push button, this state of the push button will control the LED. If you'll press it, if you'll release it, uh, uh, if this button will be in high state, you'll read this. If it will be in high state, that means if it is 1, this LED should be on. When you will press it, that means it is in low state, that time the LED should be off. So what things that we need to add on? We need to add one more pin that we are using. We need to add that pin. Which pin we are using? We are using 12, and we are using this as a output. It will be high or low depending upon whatever input that we are getting from 4. 4 we are using as input, and 12 we are using as output. So the question is, you need to define one integer. You need to define one integer. You can define one integer. Let me take a button, push button it is. You can define it. You can define it with any name. This just for this I'm taking as a button. So what you have to do, this integer, what this button is, this button is what we are reading from 4, what we are reading from 4. So here you just define one integer, button state, right? Button or any name you can give. Button state, for the clarity I have given, button state. We have used 4 as input, we have used 12 as output, we have used 12 as an output. So button state, what will be the button state? What we are reading, from 4 pin, that will be the button state. Button state, we are reading from this pin number 4. If button state is high, if it is high, then what that means, high is 1, low is 0. If it is high, you write this 12 should be high. That means LED should be on. And if else, it should be low. It should be off. That means we are controlling that LED with this push button, whether it is high or low. If it is 1, the LED will be on. If it is 0, the LED will be off. You please look at this code. What it is not a big or lengthy code that you are not able to understand. You all can able to understand. I have just defined one integer that I have given a name as button state. We have used 4 as input. I have used 12 as output. 12 is the pin number where I have connected that LED. So here in this, I have defined button state. What will be the button state? That it is reading at pin number 4, right? If this button state is high, if it is 1, that means LED should be high, LED should be on, else it should be off. This is what that is written in the code. So here when you start the simulation, it will be, it is 1, so LED is glowing. When you will press it, the LED is off. I have pressed it, so LED is off. So I have controlled that LED with this push button. Push button is released, it is on, it is 1. So if it is high, the LED is high. If it is low, the LED is off, it is low. Button, that push button is a digital button with the help of which we can control other components. We can pass on that control to the another component. Here it is a digital, so that is the reason we have used 4. 4 is a digital input pin. It is a digital pin, so it can be high, it can be low. So let's learn one more thing, because today is the last day with the Arduino. So the next thing that we will do is we will interface a LCD with it. Liquid crystal display. We will add a display unit to this Arduino, so that we should not we should have some display unit, so that we can display instead of that serial monitor, we can display thing on that display, that is liquid crystal display, right? So firstly, I'll just give you that what this LCD is. So go to, again, new circuit. If you go to the new circuit, go to the components. So this is LCD that we can interface, that we can connect with the Arduino. So whatever we are earlier, we were doing it like we were printing it on a serial monitor, that we can display over here on this display unit. So this is 16 by 2. Firstly, you must be clear with what this 16 by 2 is. It has 16 columns and 2 rows. That is basically the size of this LCD. This size of this LCD. It has 2 rows and it has 16 columns. It has 2 rows and it has 16 columns. That is the size of the LED. Now the pins of this LED. The first pin is ground. So parallelly, if you can do, because this after this will not be able to do this, get the Arduino also. This LCD and Arduino we have to interface. First connection that you have to make is ground. So ground to ground, the ground of Arduino is connected to the ground of LCD. Next is power. Power we will connect to, where will we will connect this? We'll connect it to 5 volt. Right? We will connect this VCC. VCC is power. Power we will connect to 5 volt. The next is contrast. Contrast we will keep it default. Whatever contrast, default contrast it is, we will connect it to ground. We will connect it to ground. So after this we have register select. Register select is one of the thing that is present in this LCD, that which type of register we are using, right? Which type of register we are using. So there are register, what the register is where we can store something, where the bits are stored. So whatever we have to display here, that where it is stored. So this register select is to select the register, that is register is a element where we can store n number of bits, right? It is a part of the memory. This register select we will connect again to any of the digital input output pin. You can use any digital input output pin. Next we have read write. So can you tell me, if we have to display something on a LED, we are reading or writing? We are writing. So here it is read or write. It is write. So write is it is read, it is written as read denominator write. So this we are using a write. If we are using a reading, it should be connected to VCC. If we are using a denominator, it should be connected to the ground. So this write we will connect again to ground. We are writing. We are writing. So we will connect it to ground. Here then we have a enable pin. Enable pin again you can connect to any of the digital input output pin. Next, if you look on this LCD, you have DB0 to DB7. This is called, there are 8 bits on 8-bit mode on the LCD. But when we have to display a text, it is used in 4-bit mode. It is used in 4-bit mode. That means out of these 8, only 4 are used. Like this is like DB7. You choose any 4 pin. Any 4 pins. It is to display the text. When it is to display the text, it is used in 4-bit mode. So you connect it like this. Then we have LED, that is for the backlight. LED anode, LED cathode. This LED anode, can you tell me where I'll connect this anode? Anode is positive. This we will connect to 5 volt, and this LED cathode we will connect to ground. This is for the backlight. LED, I hope you understand now LED. Now in this we are done with the connector. LED anode connected to this terminal of one terminal of register, and the other terminal connected to 5 volt. So next we will go to code, go to text. So here we have to include this library liquid crystal .h. This library we have to include because this display unit we are interfacing with the LCD. Include liquid crystal .h. This library we need to include, right? Then liquid crystal LCD, which pins we are using. Whatever pins you are using here, you are using 6 pins. One for the register select, one for the enable, and 4 are for the bit 4-bit mode. So total 6 we are using. You need to include those 6. Liquid crystal, LCD, which 6 pins you are using, you need to specify the number of those pins. Then in a setup, you need to use lcd.begin which type of LCD we are using? We are using 16 by 2, which is with 16 columns and 2 rows. What we are printing? Print hello world. This is the default thing. When we start printing, we first thing that we do. Then is set cursor 0 1. This is the position of the cursor. 0 is the first column and 1 is the second row. 16 columns it has, that is numbered as 0 to 15. 2 rows it has, that is 0 and 1. If it is 1, that means it is second row. It is printing hello world, and below this it is in the position 0 1. It is printing millisecond by 1000. What it is displaying? It is displaying that when that reset button was pressed, how much time ago that reset button was pressed. It was pressed, it is showing 2. That means I have started this Arduino 3 milliseconds ago. If I'll press this reset button, it will again get reset to 0. Right, it is again reset to 0. That this is the time when I had last pressed that reset button. This cursor position, this also I can explain. You can stop the simulation, set the cursor to eighth column. Eighth column, that means now start the simulation. It is in eighth column. Earlier it was over here, now it is in eighth column. And this second row, if you'll change this position of the cursor, this column you can choose from 0 to 15 any, and row also you can choose the first row or the second row. This is 0 or 1. This you are printing over here. You can print anything. You can use a potentiometer, and whatever the reading that potentiometer is giving, you can print it over here. If you'll print, if we'll use a potentiometer over here, whatever output we were getting from the wiper, we can print that on the LCD.
You can connect it to your laptop, mobile phone also if you have a converter. See, these are all the versions of Raspberry Pis or all the versions of IoT hardwares that are available. So you have many different versions. It is not only about Raspberry Pi. You have many different hardwares in IoT. Like these are the different versions of Raspberry Pi. Like a person from 5th standard used Raspberry Pi. And he have created a digital drawing platform.